Imagine for a moment a single bolt of lightning, jagged, luminous scar, tearing through a bruised, angry sky. It's a primal display of raw power, a spectacle that has captivated and terrified humanity since the dawn of time. A typical lightning strike, the kind that might hit a tree or sizzle in a puddle, can reach temperatures hotter than the surface of the sun. It unleashes a staggering 5 billion joules of energy, enough to power an average American household for weeks on end. The flash itself is over in a fleeting instant, just a 10,000ths of a second. Yet the sheer electromagnetic fury contained within that moment is more than what an entire city consumes in a whole week. But what if I told you that this terrifying force of nature, this ancient symbol of a god's wrath, is but a whisper in the cosmic storm? It's one of the weakest phenomena we will explore today. Welcome to a journey into the heart of the universe's most violent and powerful forces. This is a quest to find the single most powerful force in the universe. Our adventure will begin here, on our familiar planet, with phenomena we can observe and feel. We will then steadily expand our scale, moving from the destructive fury of a volcano to the cataclysmic death of a star. We will confront the very fabric of space and time, and delve into events so immense they defy human comprehension. Each step we take will reveal a new level of power, each one making the last seem like a mere flickering candle in the face of an inferno. We will journey to the surface of our sun and witness its explosive temper tantrums. We'll descend into the subterranean pressure cookers beneath our planet's crust. Then, we will travel deep into interstellar space, to the cores of massive stars that are living on borrowed time. We will encounter the ultra-dense remnants of these cosmic deaths, neutron stars and black holes, that possess gravitational fields so strong they can literally bend light and tear matter apart at an atomic level. We will explore the grand cosmic ballet of galaxies colliding, and we will witness the mysterious forces that are not only shaping our universe, but are also deciding its ultimate fate. Our odyssey will take us all the way back to the very beginning, to the moment of creation itself, and then beyond, to a terrifying theoretical possibility that could unravel our reality entirely. The universe, as we will discover, is not a quiet, peaceful place. It is a cosmic battleground of immense and constant violence, where creation and destruction are two sides of the same coin. The forces at play are far beyond anything we can replicate, let alone fully understand. They shape the stars, sculpt the galaxies, and determine the very nature of existence. So, buckle up. We're about to embark on an incredible journey into the ultimate power. We will confront the fury of nature, the destructive potential of the stars, the bizarre physics of black holes, and the mind-bending concepts that define the edge of our understanding. Our quest will culminate in a look at a force so immense it could tear apart reality itself. Are you ready to witness the most powerful forces in the cosmos? Hello, welcome back to the Astronomy Library. Solar flares, the wrath of our mother star, our sun, that familiar, life-giving orb in the sky, appears to be a picture of serene stability. It has been shining steadily for billions of years, providing the warmth and light that allowed life to flourish on Earth. But beneath that calm exterior is a roiling, chaotic cauldron of superheated plasma, governed by incredibly powerful and complex magnetic fields. On the sun's surface, these fields are constantly twisting, tangling, and coiling, storing up colossal amounts of energy, much like billions of rubber bands being stretched to their breaking point. When these magnetic field lines finally snap, they release all that stored energy in a violent, explosive burst called a solar flare. These flares are not just light shows. They are staggeringly powerful events. In an instant, a single, medium-sized solar flare can release as much energy as 10 billion nuclear bombs detonating at the same time. The energy is released across the entire electromagnetic spectrum, from radio waves to X-rays and gamma rays, sending a wave of radiation screaming through the solar system. But the real threat comes from a related phenomenon: coronal mass ejections, CMEs. Often, when a solar flare goes off, it also hurls billions of tons of magnetized plasma from the sun's outer atmosphere, the corona, into space. These CMEs are not just radiation. They are a physical wave of charged particles traveling at millions of miles per hour. If one of these is headed our way and slams into Earth's magnetic field, the consequences can be profound. In the year 1859, the most powerful CME ever recorded, now known as the Carrington event, struck Earth. It was so intense that telegraph systems, the most advanced technology of the era, caught fire and sparked, shocking telegraph operators. The aurora borealis, typically only seen in the far north, was visible as far south as the Caribbean. Today, with our global society so reliant on technology, a similar event would be catastrophic. Our planet is now enveloped in a web of power grids, communication satellites, and GPS networks. A modern Carrington-level event could induce powerful electrical currents in long power lines, causing them to overload and burn out transformers. It could fry critical satellite systems, disrupting everything from global communications to navigation. In a worst-case scenario, it could send our modern digital civilization hurtling back to a pre-digital age, all from a single cosmic belch from our quiet, friendly sun. These solar flares and CMEs are a constant reminder that even the most familiar and seemingly benign objects in the cosmos harbor a potential for unimaginable destruction. The sun is not just a source of life. It is a source of immense, untamed power that we can only hope to understand and prepare for. Supervolcanoes, Earth's slumbering giants. While the sun's fury is a constant threat from space, our own planet, a seemingly stable and life-sustaining world, holds its own secret reservoirs of unimaginable power. Deep beneath the serene landscape of Yellowstone National Park, a gigantic bubble of molten rock and superheated gas is slowly, inexorably building pressure. This isn't just a volcano. It's a supervolcano, a class of volcanic systems so massive that their eruption would make every other volcanic event in human history look like a mere firecracker. The Yellowstone caldera, a massive depression 40 miles wide, is a visible scar from a past eruption. But the real beast is hidden below. It works like a pressure cooker from hell. Magma, heated by the Earth's mantle and core, collects in a colossal underground chamber. Over hundreds of thousands of years, this magma chamber swells, building immense pressure as it absorbs more and more heat and gas. The ground above it, a thin, fragile crust, is all that holds this cosmic rage at bay. When the pressure finally becomes too great, and the crust can no longer contain the force, it won't just explode. It will literally tear a hole in the Earth. The eruption of a supervolcano is not a conical mountain spewing lava. It's a cataclysm that would blast billions of tons of rock, ash, and gas into the atmosphere. The eruption itself would be so powerful, it would be heard 3,000 miles away. A massive cloud of ash, pumice, and sulfur dioxide would blanket the entire northern hemisphere. This ash would block out sunlight for years, plunging the world into a volcanic winter. Global temperatures would plummet, and acid rain would fall, poisoning water sources and destroying crops on a global scale. The delicate balance of our planet's ecosystem would be shattered, leading to mass famine and a potential collapse of human civilization. The last major eruption at Yellowstone was about 640,000 years ago. It spewed enough material to bury the entire state of Texas under 2 feet of volcanic ash. Scientists believe these events happen on a cycle of roughly 600,000 to 800,000 years. We are, at this moment, living in a quiet period between these cataclysms. While it's impossible to predict exactly when the next eruption will be, it's not a question of if it will happen, but when. The supervolcano is a visceral reminder that the forces that shaped our planet are still active, and they are capable of a violence that can redefine life on Earth. Lightning, nature's electromagnetic fury. Even the subterranean fury of a supervolcano pales in comparison to the raw electrical chaos that dances across our skies. We're talking about lightning, a phenomenon so powerful that it creates a natural shockwave we call thunder, a sound so loud it can rattle the windows in your home. Every day, lightning flashes across our planet's surface 5 million times, a constant, spectacular display of pure electromagnetic power. Inside a thundercloud, a fascinating process of charge separation occurs. As warm, moist air rises, it carries tiny water droplets and ice crystals with it. These particles collide violently, transferring electrons. Heavier, negatively charged particles collect at the bottom of the cloud, while lighter, positively charged particles accumulate at the top. This creates an enormous potential difference, or voltage, that can reach up to 1 billion volts between the cloud and the ground. When the electrical tension becomes too great, nature finds a path of least resistance to equalize the charge. A faint, invisible channel of ionized air, called a stepped leader, snakes its way down from the cloud toward the ground in a series of lightning-fast steps, moving at an astonishing 200,000 miles per hour. As this stepped leader nears the ground, it draws a positive charge upward from the Earth, often from tall, pointed objects like trees, buildings, or even humans. The moment this upward streamer of positive charge connects with the stepped leader, the circuit is complete. The result is a massive, blinding surge of pure electrical energy. The return stroke that zips back up the ionized channel, at an incredible 1/3 the speed of light. This is the flash of light you actually see. It can carry up to 30,000 amps of current, far more than the measly 15 amps in your home wall socket. Nuclear weapons. Man-made star power. Lightning is a spectacular natural force, but humanity has managed to harness the very power that fuels the stars and direct it in a far more destructive way. The most powerful man-made device ever detonated was the Soviet Tsar Bomba, a hydrogen bomb tested in 1961. This single device released the energy, equivalent to 57 million tons of TNT, in a single blast. The mushroom cloud rose to an incredible height of 39 miles into the atmosphere, nearly reaching the edge of space. The fireball was 5 miles wide, and the flash of the explosion was visible from over 600 miles away. The shockwave traveled around the world 3 times, and the resulting ground tremor registered as a 5.0 magnitude earthquake worldwide. Nuclear weapons work by releasing the immense energy locked inside the atomic nucleus, the very glue that holds matter together. Fission bombs operate by splitting heavy atoms like uranium or plutonium. A small initial blast forces these atoms to split, releasing neutrons that then split other atoms in a runaway chain reaction. This chain reaction releases a colossal amount of energy in an instant, but fusion bombs, or thermonuclear bombs, take this power a step further. They use a fission bomb as a trigger, creating the extreme heat and pressure necessary to force light atoms, like hydrogen, to fuse together. This is the same process that powers our sun and every star in the universe. The energy released in this fusion process is even greater than fission. At the heart of this destructive power is Einstein's famous equation, E equals mc. 2. This equation shows that a tiny amount of mass meter can be converted into a tremendous amount of energy, E, because it is multiplied by the speed of light squared c. 2. An unimaginably large number. In the case of the Tsar Bomba, less than 2 pounds of matter was converted into pure energy, but it created an explosion thousands of times more powerful than the bombs dropped on Hiroshima and Nagasaki combined. It is a chilling testament to humanity's ability to unlock and weaponize the fundamental forces of the cosmos, giving us the power to create a localized, man-made version of a star's heart. Supernova, the explosive death of a star. Asterisk, nuclear weapons, for all their destructive power, are a pale imitation of the natural cosmic events that they seek to replicate. In the constellation Orion, a star 700 times the size of our sun named Betelgeuse is nearing the end of its life. When this massive star finally dies, it will do so in a brilliant, cataclysmic explosion called a supernova. In just the first 10 seconds of this explosion, a supernova releases more energy than our sun will produce in its entire 10 billion year lifespan. A star's life is a constant, epic battle between two forces, the outward pressure of nuclear fusion pushing against the inward crush of gravity. For millions of years, a massive star like Betelgeuse fuses lighter elements into heavier ones, starting with hydrogen and ending with a core of iron. Iron is the final fuel. Unlike lighter elements, fusing iron requires energy instead of releasing it. This is the star's death knell. The nuclear engine suddenly sputters and dies, and gravity, which has been held at bay for eons, finally wins the battle. In less than 1 second, the star's core collapses catastrophically. The core, which was once the size of Earth, is crushed down to the size of Manhattan, forming a super-dense neutron star. This collapse creates an unimaginable shockwave that travels outward at 20,000 miles per second, tearing the star apart from the inside out. The resulting explosion is a cosmic forge, a factory of heavy elements. The intense energy and pressure of the supernova force atoms to fuse into elements heavier than iron. including the gold, platinum, and uranium found on Earth. This material is then hurled into space, enriching the cosmos and providing the raw ingredients for the next generation of stars, planets, and even life itself. A supernova is not just a destructive event. It is the ultimate act of cosmic recycling, a violent but essential process that provides the very building blocks for the universe as we know it. The Crab Nebula, a beautiful glowing remnant in our galaxy, is a testament to this process. The scattered guts of a supernova that was witnessed and recorded by ancient Chinese astronomers in 1054 add neutron stars, cosmic diamonds of density. The explosive death of a massive star, a supernova, leaves behind one of the most extreme and bizarre objects in the universe, a neutron star. This is not a star in the traditional sense, but a superdense relic, a cosmic diamond born from a violent cataclysm. While it's only about 20 miles across, the size of a small city, a neutron star packs twice the mass of our Sun into that tiny sphere. The density is staggering, so extreme that our human minds struggle to comprehend it. If you could somehow scoop up a single teaspoon of neutron star material, it would weigh an impossible 6 billion tons on Earth. That's the weight of a mountain. Drop that teaspoon from waist height, and it would punch a hole clean through the planet, out the other side. This density is the result of the immense gravitational pressure of the supernova explosion, which crushes protons and electrons together to form a solid, uniform mass of neutrons. The atomic structure itself collapses, and the result is a giant atomic nucleus with no empty space between the subatomic particles. The gravity on a neutron star's surface is 200 billion times stronger than Earth's gravity. If you were to somehow stand on its surface, your body would be flattened into a paper-thin sheet in a microsecond. The gravitational force so powerful, it would break down your very molecules. As the star's original mass collapses, its rotation speeds up dramatically due to the conservation of angular momentum. A star that once took a month to rotate now spins at incredible speeds, with some neutron stars completing over 700 rotations per second. This spinning ultra-dense monster is the remnant of a supernova, a cosmic beacon of immense power, and far more powerful than the star that created it. Pulsars, the universe's lighthouses of death. Some neutron stars, with their incredible rotation and density, take their power to another level entirely. We call these objects pulsars. A pulsar is a rapidly rotating neutron star that has a powerful magnetic field, with its magnetic poles not aligned with its rotational poles. This misalignment causes the pulsar to emit incredibly focused beams of electromagnetic radiation from its poles, like two cosmic spotlights. As the neutron star spins, these beams sweep across the galaxy like a lighthouse. When one of these beams points directly at Earth, our radio telescopes detect a short, precise pulse of energy. The pulses from these objects are so regular and predictable that they are more accurate than any man-made clock. The fastest known pulsar, designated P, completes an astonishing 716 rotations every second, a speed so fast it's mind-bending. The surface of this pulsar is moving at nearly a quarter the speed of light. This spinning powerhouse is not just a cosmic curiosity, it's an engine of immense energy. The beams it fires are so energetic that if a pulsar were located just 30 light-years from Earth, and one of its beams were pointed in our direction, the radiation would strip away our atmosphere and sterilize the planet within a matter of minutes. The discovery of pulsars was initially so baffling that scientists thought the regular pulses might be signals from an extraterrestrial civilization, which they jokingly nicknamed Little Green Men. We now know that these signals are the natural result of extreme physics. A pulsar is a testament to the raw, untamed power that can be unleashed when immense mass is compressed into a tiny space. It is a cosmic lighthouse of death, silently sweeping its beams across the galaxy, a constant reminder of the incredible forces at play in the universe. Magnetars, the magnetic monsters, even pulsars, with their extreme rotation and density, are outshone by a rarer and even more terrifying class of neutron star, the magnetar. A magnetar's defining characteristic is its outrageously powerful magnetic field. While a typical pulsar's magnetic field is already trillions of times stronger than Earth's, a magnetar's field can be a quadrillion times stronger. This is a force so immense that it is almost impossible for our minds to comprehend. If a magnetar were placed halfway to the moon, its magnetic field would be so powerful that it would instantly erase every credit card on Earth. This is a magnetic force that can literally deform atoms, twisting and stretching them out of shape. The photons of light themselves, which are normally unaffected by magnetic fields, are forced to split and interact with each other in a magnetar's field. This is not a force we can see or feel, but one that is so strong it can alter the very laws of physics as we know them. But the real show of a magnetar's power comes from what is known as a starquake. The magnetic field of a magnetar is so powerful that it creates a massive strain on the star's ultra-dense crust. When this strain becomes too great, the crust of the neutron star cracks, sending out a shockwave that rips through its magnetic field. The most powerful magnetar ever observed, designated SGR 1806-20, had one such starquake in 2004. In just 1/10 of a second, it released more energy than our Sun produces in 150,000 years. The blast was so intense that it rattled Earth's magnetic field, causing it to distort from 50,000 light-years away. A magnetar is a monster of magnetic fury, a cosmic beast that can unleash a galactic-level event in the blink of an eye. Asterisk, neutron, star collisions, cosmic gold factories. Asterisk, the violent deaths of single stars pale in comparison to the cataclysmic dance of two neutron stars. When two of these superdense relics orbit each other, they are locked in a gravitational spiral of death. For millions of years, they slowly lose energy by emitting gravitational waves, which are ripples in the very fabric of space-time itself. This loss of energy causes them to get closer and closer, spinning faster and faster, until in the final moments of their existence, they are rotating up to 1,000 times per second. They smash together in one of the most violent events since the Big Bang. This collision, known as a kilonova, is an explosion of unimaginable power. For a fleeting instant, it releases more energy than our Sun will produce in its entire 10 billion year lifetime. It is a blast so powerful that it forges heavy elements like gold, platinum, and uranium. These precious metals cannot be created in the hearts of stars. They require the extreme pressures and temperatures of a kilonova to be formed. The collision is a cosmic gold factory, and it is the primary source of these heavy elements in the universe. They are then flung into space, enriching the cosmos and providing the raw ingredients for the formation of new stars, planets, and even the jewelry you wear. The power of a kilonova is so immense that it creates a new kind of radiation, powerful enough to be detected across billions of light-years. In 2017, the LIGO and Virgo observatories detected gravitational waves from such a collision, providing the first direct evidence of these events. The fact that we could detect these ripples in space-time from a galaxy a billion light-years away proves that the collision was powerful enough to literally shake the very foundation of reality. A neutron-star collision is not just an explosion. It is a profound cosmic event that changes the very composition of the universe. Hypergent stars, the self-destructive giants. Asterisk, even neutron-star collisions, as violent as they are just the end of a cosmic story that begins on a truly massive scale. Meet Uy Scuti, a star so large that if you placed it at the center of our solar system, its surface would extend beyond the orbit of Jupiter. This Hypergent is a star that has a mass more than 30 times that of our Sun, and is so luminous that it's 100,000 times brighter. These stars live fast and die young. They burn through their nuclear fuel at a reckless, ferocious pace, consuming themselves in just a few million years, compared to our Sun's leisurely 10 billion year lifespan. This immense energy output makes them incredibly unstable. The outward pressure from their massive fusion reactions is barely balanced by the inward crush of their own gravity. They pulsate and shed their outer layers in powerful stellar winds, blowing material into space at 100,000 miles per hour, essentially tearing themselves apart from the outside in. The immense gravity of these hypergents has a profound effect on space-time, warping and curving it in their immediate vicinity. A hypergent like Uy Scuti is so massive that it can skip the supernova stage entirely. When it finally runs out of fuel, the star's core collapses directly into a black hole, creating a cosmic singularity that swallows its entire mass in a single violent act. This event, known as a direct collapse supernova, is a rare but powerful way to form a stellar mass black hole. A fittingly violent end for a star that spent its life on the edge of destruction. Wolffray Stars, the great self-eaters. Astea. Special class of hypergents, known as Wolffray Stars, takes self-destruction to an art form. These stars are so hot up to 200,000 degrees Fahrenheit on their surface that their powerful stellar winds are stripping away their outer layers at a ferocious rate. WR102, for example, is losing the equivalent of an Earth's mass every 10,000 years. Wolffray Stars are essentially the stripped-down, exposed cores of massive stars. They have burned through all their outer layers of hydrogen and are now fusing heavier elements like helium, carbon, and oxygen. The intense radiation pressure from this fusion process is so strong that it pushes the star's own material away, creating a spectacular stellar wind that carves out vast, glowing nebulae. These nebulae are a testament to the star's self-destructive nature, a cosmic trail of breadcrumbs left behind as the star consumes itself. Wolffray stars are the final, chaotic phase of a massive star's life before it goes supernova. They are so luminous that they can outshine hundreds of thousands of suns, and their winds are so energetic they can ionize the gas and dust in the surrounding nebula for hundreds of light years. The eventual supernova explosion of a Wolffray star is a particularly violent one, as the star's core has already been exposed and is ready for the final collapse. The material from these explosions is flung into space, enriching the cosmos with the heavy elements forged in the star's core. Gamma ray bursts, the ultimate destructive blast. The most powerful explosions we have witnessed in the universe are not supernova or neutron star collisions. They are a different kind of cosmic cataclysm, a gamma-ray burst, GRB. These bursts of high-energy radiation can release more energy in a few seconds than our sun will produce in its entire 10 billion-year lifetime. They are born from the collapse of a supermassive star into a black hole, and they are a force of destruction, so powerful they could sterilize a planet from across the galaxy. When a star, at least 20 times the mass of our sun, dies, it can't just go supernova. The core collapse is so violent that it forms a black hole. As matter swirls into the newly formed black hole, it is accelerated to nearly the speed of light and funneled into two narrow, powerful jets of plasma that are shot out from the black hole's poles. These jets are so energetic they can pierce through the outer layers of the collapsing star and race across space for billions of light years. A single GRB can release more energy in its short duration than our sun will produce in its entire lifetime. If a GRB were to occur within a few thousand light years of Earth and its jet were pointed directly at us, its high-energy radiation would strip away our atmosphere, destroy the ozone layer, and expose the planet's surface to a sterilizing bath of radiation. All life on the side of the planet facing the blast would be instantly vaporized. The famous GRBO 80916C, which was detected in 2008, was so powerful that if it had occurred within our galaxy, its burst of gamma rays would have been bright enough to be seen with the naked eye. Gamma ray bursts are a chilling reminder that the universe is not just beautiful, it is also capable of a level of violence that is truly apocalyptic. Stellar mass black holes, the ultimate cosmic drains. The gamma ray bursts we just discussed are born from the ultimate cosmic endgame, the collapse of a star into a black hole. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. The boundary of a black hole is called the event horizon, and once you cross it, you're on a one-way trip to a point of infinite density at the center, called the singularity. Stellar mass black holes are the most common type, forming from the deaths of massive stars. They are typically between 3 and 20 times the mass of our sun. As matter falls into a black hole, it is accelerated to incredible speeds and heated to billions of degrees, forming a glowing accretion disk that can outshine entire galaxies. The gravitational forces near a black hole are so extreme that they would pull you apart, a process known as spaghettification. Your body would be stretched and elongated into a long, thin strand of atoms before you even reach the event horizon. The Power of a black hole is not in its size, but in its gravitational pull. A black hole with the same mass as our Sun would have the same gravitational pull. But its extreme density means you could get much closer to it before the gravity becomes inescapable. This immense, invisible gravitational power is what makes black holes the ultimate cosmic drains, silently consuming matter and energy and representing the final, violent act of stellar death. Asterisk. Supermassive black holes. Cosmic monsters at the galactic core. Asterisk. As terrifying as stellar mass black holes are, they are mere firecrackers compared to the cosmic monsters that lurk at the center of most galaxies. These are supermassive black holes, and they are the true gravitational anchors of the universe. Our own galaxy, the Milky Way, is home to Sagittarius A*, a supermassive black hole that is 4 million times more massive than our Sun. In the heart of the galaxy, M87, a black hole weighs an incredible 6.5 billion times the mass of our Sun, with an event horizon larger than our entire solar system. These supermassive black holes act as the gravitational anchors for their galaxies, controlling the motion of billions of stars across thousands of light years. They grow by consuming matter and merging with other supermassive black holes during galactic collisions. Their influence is so profound that they can affect the rate of star formation across their entire galaxy, acting as cosmic regulators of galactic life. The powerful winds and jets they can produce can sweep away gas and dust, preventing new stars from forming. The formation of supermassive black holes is still a mystery. We believe they either formed from the collapse of gigantic gas clouds in the early universe, or from the mergers of countless smaller black holes. Their very existence is a testament to the immense power of gravity on a galactic scale, a force so strong that it can hold together an entire galaxy of billions of stars and shape its evolution for billions of years. Asterisk. Quasars, the universe's brightest torches. Asterisk. When a supermassive black hole goes on a feeding frenzy, it can become a quasar. Quasars are some of the brightest objects in the universe, so luminous that they can outshine entire galaxies with the light of 1 trillion suns. This incredible light show is powered by the black hole's accretion disk, which is a swirling vortex of gas and dust being superheated to millions of degrees as it spirals into the black hole. The friction and gravitational forces within this disk are so immense that they generate an incredible amount of energy, far more than can be explained by nuclear fusion alone. Quasars were much more common in the early universe when galaxies were richer in gas and dust. They are essentially the active, loud phase of a supermassive black hole's life, a period of violent feeding that can last for hundreds of millions of years. The energy released by a quasar is so immense that it can influence star formation and the evolution of its host galaxy for billions of years. The radiation from a quasar can even clean out the galaxy, pushing away gas and dust and bringing star formation to a halt. Quasars are not just powerful sources of light, they are also powerful sources of radio waves, X-rays, and gamma rays. They are a testament to the incredible power of supermassive black holes, and their study provides us with a window into the early universe, allowing us to see how galaxies formed and evolved over cosmic time. Supermassive black hole jets, cosmic flamethrowers. Asterisk. Not all supermassive black holes are quasars. Some, like the one in the galaxy M87, produce powerful jets of plasma that are accelerated to nearly the speed of light. These relativistic jets are one of the most powerful displays of cosmic power. They are so energetic that they can extend for thousands of light years, acting as cosmic flamethrowers that blast through the intergalactic medium. These jets are formed by a combination of the black hole's rotation and its intense magnetic fields. As matter swirls into the black hole, the magnetic field lines get twisted and tangled, creating a powerful engine that funnels and accelerates the plasma into two narrow, highly focused beams. The energy contained in a single jet is equivalent to the total mass energy of several suns. The jets from the M87 black hole are so bright that they can be seen from Earth, even though the galaxy is 55 million light-years away. These jets have a profound impact on their galactic and intergalactic environment. They can create vast bubbles and cavities in the hot gas surrounding their galaxy, influencing star formation in neighboring galaxies. When these jets are pointed directly at us, we call them blazars. And their incredible luminosity can change by a factor of 100 in just a few hours. These jets are a testament to the incredible power of supermassive black holes. A force so strong it can create beams of energy that can travel across the universe and influence galactic evolution. Asterisk. Galactic collisions. The grand dance of destruction. Asterisk. The most powerful forces in the universe are not just localized explosions. They can be a grand, cosmic dance of destruction and creation. In about 4.5 billion years, our Milky Way galaxy will collide with the Andromeda galaxy, its nearest major neighbor. This cosmic collision, though it sounds catastrophic, is a graceful slow-motion ballet of gravity. Individual stars are so far apart that they rarely collide. Instead, the gravitational forces of the two galaxies will tear and reshape each other, flinging stars into new orbits and triggering massive bursts of star formation as gas clouds are compressed. The two galaxies will pass through each other, stretching and deforming, before a final permanent merger creates a new, giant elliptical galaxy, which scientists have nicknamed Milky. The two supermassive black holes at the centers of the galaxies will eventually merge in a final act of violence. A cataclysm that will emit powerful gravitational waves that ripple through the universe. Galactic collisions are a fundamental part of the universe's evolution. They are a destructive force that can tear apart galaxies, but they are also a creative force that can trigger new waves of star formation. The immense gravitational power of a galactic collision is one of the most powerful forces in the universe, an event that can change the destiny of billions of stars and shape the future of a new galaxy. Asterisk. Galaxy clusters and dark matter, the invisible power. Asterisk. Galactic collisions and mergers lead to even larger structures. Galaxy clusters. The Coma Cluster, for example, is a gigantic city of over 1,000 galaxies bound together by gravity. These clusters are the largest gravitationally bound structures in the universe, and their immense gravitational power is a force to be reckoned with. They bend and distort the light from distant galaxies, a phenomenon called gravitational lensing, which allows us to see the gravitational influence of the cluster. But the visible galaxies and the hot X-ray emitting gas in these clusters only account for about 15% of the total mass. The rest, a staggering 85%, is a mysterious, invisible substance called dark matter. We cannot see or feel dark matter. It doesn't emit or reflect light, but we can see its gravitational influence. Dark matter is the invisible scaffolding of the universe, providing the gravitational glue that holds these massive structures together. Without dark matter, galaxy clusters would simply fly apart as they spin at incredible speeds. Dark matter is the most abundant form of matter in the universe, and its gravitational influence is a cosmic force of immense power. It is the force that keeps galaxies from flying apart, and it is the force that allows galaxy clusters to form and grow. We don't know what dark matter is made of, but we know its gravitational power is a fundamental force in the cosmos, a silent and invisible power that shapes the universe on the largest possible scales. Asterisk. Cosmic voids and dark energy, the universe's grand design and final fate. Asterisk. Looking at the universe on the largest possible scales, we see a vast cosmic web of galaxy clusters and filaments surrounding enormous regions of empty space called cosmic voids. These voids are the largest structures in the universe, spanning hundreds of millions of light years. They are not just empty. They are the result of a powerful, repulsive force that is constantly pushing space apart. This mysterious, invisible force is called dark energy, and it accounts for 68% of the universe's total energy density. Dark energy acts as a kind of anti-gravity, accelerating the expansion of the universe and pushing galaxies farther apart at an ever-increasing rate. We don't know what dark energy is, but we know its effects are profound. It is the force that is carving out the cosmic voids, and it is the force that is driving the universe toward a chilling fate. If this trend continues, the universe could face a big rip scenario, where dark energy eventually becomes so powerful that it tears apart galaxies, then stars, then planets, and eventually even atoms themselves. The universe would end not with a bang, but with a whimper. As the fundamental forces that hold matter together are overwhelmed by the repulsive force of dark energy. Dark energy is a cosmic force of immense power, a force that is shaping the final destiny of our universe. It is a reminder that the most powerful forces in the cosmos are not always the ones that make a loud bang. Sometimes they are the silent, invisible forces that are slowly, inexorably driving the universe toward its ultimate fate. The Big Bang, the origin of reality. Before the cosmic voids and dark energy, before the stars and galaxies, there was the Big Bang, about 13.8 billion years ago. The entire observable universe was compressed into a space smaller than a single atom, a state of infinite density and heat, a singularity. The Big Bang wasn't an explosion in space, but an explosion of space itself. This event created space, time, matter, and energy, and set the universe on a path of rapid expansion and cooling. In the first moments, the universe was a superheated plasma, a soup of elementary particles. As it expanded and cooled, these particles began to form protons and neutrons, which then combined to form the first atoms, mostly hydrogen and helium. The echo of the Big Bang, a faint glow called the cosmic microwave background, CMB radiation, still permeates the universe today. It is a snapshot of the universe about 380,000 years after the Big Bang, when it had cooled enough for the first atoms to form and for light to travel freely. The tiny fluctuations in the CMB are the seeds from which all the galaxies, stars, and planets in our universe grew. The Big Bang is the most powerful event in the history of the universe, a moment of creation so violent and profound that it created all of reality as we know it. It is the ultimate source of all the power we have discussed so far, a moment of unimaginable energy that set the stage for everything that has happened since. Cosmic inflation, the exponential bang, but the Big Bang itself may have been preceded by an even more violent event. In the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion called cosmic inflation. During this time, the universe grew faster than the speed of light, stretching from a subatomic size to something larger than a grapefruit in an instant. Inflation was driven by a hypothetical energy field called the inflaton, which created a powerful anti-gravity effect that caused the universe to expand at an exponential rate. This rapid expansion smoothed out the universe, making it incredibly uniform on a large scale. It also amplified tiny quantum fluctuations in the early universe, turning them into the large-scale structures we see today, the cosmic seeds from which galaxies would eventually grow. Inflation also provides a solution to several cosmological puzzles, such as why the universe is so flat and uniform. It also suggests that our universe might be just one of many, a single bubble in a vast and infinite multiverse. The immense power of inflation is a testament to the bizarre and mind-bending physics of the early universe, a force so powerful that it could create a universe from almost nothing. Vacuum decay, the quantum apocalypse. The terrifying possibility exists that our universe, for all its majesty and violence, is not truly stable. According to a theory called vacuum decay, the universe may exist in a false vacuum state, a temporary but stable energy level. A tiny quantum fluctuation in some corner of the cosmos could trigger a phase transition, creating a bubble of true vacuum that would expand at the speed of light. This bubble would be a wall of destruction, a wave of reality-altering power. The laws of physics inside the bubble would be radically different from our own. As the bubble expands, it would convert everything it touches, every atom, every molecule, every star, every galaxy, into a new, radically different state of being. The new reality inside the bubble would be uninhabitable, and the destruction would be unstoppable. We wouldn't even see it coming, as the bubble would move at the speed of light, erasing our universe in an instant. The immense power of vacuum decay is not just in its destructive potential, but in its ability to fundamentally change the laws of physics themselves. It is a theoretical but chilling possibility, a reminder that the most powerful force in the cosmos may be a force that could completely unravel our reality. The multiverse, the existence of infinity. What if our universe is just one of an infinite number? The multiverse theory, which arises from inflation, suggests that there is a vast collection of parallel universes, each with its own laws of physics, different constants, and unique histories. In this scenario, every possible outcome of every decision you've ever made exists in a parallel universe. There are universes where gravity repels instead of attracts, where time runs backward, and where the fundamental forces of nature are completely different. The multiverse theory provides an elegant explanation for why our universe seems so perfectly fine-tuned for life. If there are infinite universes, it's not a coincidence that we find ourselves in one where the laws of physics allow for stars, planets, and life. It's an inevitability. The true, ultimate power in this scenario is not in any single universe but in the larger framework that allows for the creation of all possible realities. The multiverse is the ultimate expression of power, a concept so vast it encompasses everything that has ever been, is, or could be. Conclusion: the endless battle of the cosmos. We began our journey with a solar flare, a force capable of unimaginable destruction on a planetary scale. We then moved to supervolcanoes that can alter our planet's climate, to lightning bolts that contain the power of a city, to nuclear weapons that harness the power of a star. But then we moved beyond the familiar, to the supernova deaths of stars that outshine galaxies, to the ultra-dense neutron stars and black holes that warp reality itself, and to the cataclysmic collisions and explosions that forge new elements and shake the fabric of space-time. We discovered that even these incredible forces are dwarfed by the mysterious dark energy that is tearing the universe apart and the initial moments of the Big Bang that created reality. And finally, we ended our journey with the mind-bending concepts of vacuum decay and the multiverse, which suggest that even our entire universe may be a fleeting, fragile part of an infinite collection of realities. So what is the most powerful force in the universe? Is it the quantum scale fluctuations that seeded the Big Bang? The gravity of a black hole that can tear apart a star? Or is it the unseen dark energy that will determine the final fate of our cosmos? The answer may be that there isn't one. The universe is a hierarchy of power, with each level controlled by a force that makes the one below it seem insignificant. The cosmos is a cosmic battleground of creation and destruction, and we are privileged to be able to glimpse its uninspiring fury. We live in a universe of immense power, a universe of constant change and violent transformation. And the search for the most powerful force is not just a search for an answer. It is a search for a deeper understanding of the very nature of existence.